Hi guys, my name is Terry. In this video, I'm going to go through the Additional Mathematics SPM trial paper for year 2022. And this is Sekolah Berasrama Penuh SBP paper 1. Okay, let's get straight to question number 1. So this is a question on the chapter Indices, Surds, and Logarithm, right? Now, for the first part, you have to use logarithm, simplify it, and we have to use the formula for changing the base of logarithm. Now you can see the bases that you're given here, they are different. This is base 5, this is base 3, and this is base 3. So what we can do is we can change everything to the same base. In this case, I guess the easiest base to use is base 10, right? Because when you use base 10, we just have to write LG. LG is a short form for log base 10. And then remember, let me just run through with you the formula for changing base. If you have log base A, B, we can introduce a new base, let's say base C, base C. The original number B stays on top, the original base A stays down. Now, in this case, for the first logarithmic term, log base 5, 16, we are going to introduce the new base, which is base 10. I'm going to write LG. 16 stays on top, 5 stays down. Now, for the second one, we have log base 3, 1 to 5. Again, I'm going to write LG here, 1 to 5 stays up, 3 stays down. Now, for the third one, which is log base 3, 4. Again, I introduce log base 10, LG, 4 stays on top, 3 stays down. Now, we know 16 can be written as 4 power 2. So I could put a 4 here. The power 2 I transfer in front. For those who are not sure about this, let me write down the formula for changing the we call it the power rule. Log base ax to the power m, we can actually bring the power in front and write log base ax. So in this case, 16 here, I'm changing my 16 to 4 power 2, and I'm bringing the power in front. You get to LG4. Now, I know you'll be thinking, why don't we use 2 power 4? The reason why I don't change to 2 power 4 is because I can see there is a log base 4 over here that we can actually cancel out, right? If you change to base 2, then this 4, you will have to change to base 2 as well. So we'll just leave it as base 4. Keep your LG5, yep. And then for 1 to 5, 1 to 5 is 5 power 3. Now I'm going to put the 3, bring it in front here. You still have a LG3. Now, when you divide a fraction with another fraction, we can take this fraction and flip it upside down, as in we write LG3 on top, LG4 below. Now, at this stage, we can cancel or simplify some of this. Like, for example, I think I can cancel LG5, and we can cancel LG4 and LG4. Now, we still have a 2 in front, a 3 here. Well, you can multiply it, or we can just keep it as 2 times 3 over LG3. As for LG3, remember, square root means power half. Square root 3 is 3 power half. That power half, right, instead of leaving as 3 power half, I'm going to transfer it in front. So it's going to be half LG3. Now, again, at this stage, we can cancel them out. I think I'm going to cancel LG3 and LG3 here. I'm left with 2 times 3 times half. The half and 2 can cancel off. My final answer is just 3. Yep. I think this is fairly simple. All right, for part B, I'm going to do it over here. I'm supposed to solve this equation. Surd x minus 2 equals surd x minus 1. Well, what we can do is we can square both sides right away. I'm going to take a square on the left and square this on the right. The reason why you want to square, because we want to get rid of the square root. When I square this, the square root disappears. I'm left with x minus 2. Now, for square root x minus 1 square, remember we are expanding it in the form of a plus b square, which gives us a square plus 2ab plus b square. So in this case, my a is surd x, we square it. You can write x straight away. Yeah, surd x, if you square it, you cancel out the square, right, and square root. You are left with x. And then the middle term is 2ab. Yeah? But because you have a negative here, so it's a minus 2 times surd x times -1, so it's -2 surd x. And then -1, if I square it, I get 1. I remember -1 square gives us 1. I'm using the expansion of a plus b squared. Now, with that, we can cancel out this negative. Right? There's a lot negative we can cancel, or maybe we just cancel the x first, right? And I would prefer to carry this to the left. Maybe you bring this to the right. The -2 surd x, if I bring over to the left, it becomes +2 surd x. -2 bring to the right becomes +2. 2 plus 1 is 3. Surd x is now 3 over 2. And to find x, we just square left and right. Yeah? When you square this, you get 3 squares 9, 2 squares 4. Your final answer, x is 9 over 4. Okay, to answer this question, some people may say, why don't we put a plus minus? Okay, be careful with the plus minus. Because some people may think that when we have square root x x squared equals to 4, right? Yes, you need to put a plus minus 4, square root 4, which is plus minus 2. Why? Because a negative number, when you square it, you get +4, +2. When we square it, we still get +4. So when we say x squared equals to 4, that x can take two answers. It can take either the negative number or the positive number, right? So when you have an unknown x with a square and I bring the square over, becomes a square root, remember to put a plus minus because your x can take two possible answers, can be positive, can be negative. Now, however, this is not the case to use a plus minus because you can see the x inside the bracket, inside the square root. Can we square root number 1? Some of you may say, I thought we should put plus minus. Can we square root a negative here? No, obviously not. We can only square root a positive number, right? So when you are bringing this over, your x value is in the square root, inside square root. Your x can only have one answer. You don't go and put a plus minus. Some people may get confused and yeah, adding a plus minus instead. Okay, question number 2. This is from the chapter progression. In fact, this is an arithmetic progression. T1, T2, T3, they are the first 3 consecutive terms of an arithmetic progression is given that your T1 is 7 and Tn plus 1 is Tn plus 4. So what is the meaning of this? Actually, this itself tells us that your common difference is 4. So if you don't understand the meaning here, Tn equals to Tn plus 1 equals Tn plus 4. If you bring this over, this is Tn plus 1 minus Tn, isn't it? It's like T2 minus T1. Or T3 minus T2, where n is an integer, yeah, positive integer, yeah. So this actually represents your common difference. Your common difference is 4. Now we're supposed to find the 17th term. Okay, we know our A. Our A is 7. T1 is 7. We know our common difference. To find P17, just use the formula. Remember, Tn equals to A plus n minus 1D. A is my first term. My first term is 7. My n is 17. 17 minus 1. Let me write 16 straight away. My d is 4, right? So 16 times 4 is 64. You add with 7, you get 71. You're not sure you can use a calculator, okay? 7 plus 16 times 4. There you go. 71. Okay, question number 3, this is from the chapter function. I would say quite a fairly simple question. So you're given fx equals 2x plus 4, and you're supposed to find f2x. So what is f2x? f2x is what we call an iterated function or repeated function. Is the case where putting fx inside fx. Now, my fx is 2x plus 4. I'm going to put inside my fx once again. So it's, remember, if fx equals to 2x plus 4, you got a thin bracket. If I have 2x plus 4 here, I must put 2x plus 4 here. So it's a 2 over 2x plus 4 plus 4. Okay, let us expand the bracket times in 1 by 1. So this will give us 4x plus 8 plus 4. Now, this will give us 4x plus 12. Yep, simple. Okay, second part, we're finding the value of m such that f2 of 2m is now 28. Now we can use the result here. We know our f2x is 4x plus 12. f2 of 2m will be putting 2m inside here. This will give us 4 of 2m plus 12 equals 28. Now 4 times 2 is 8, so 8m plus 12 equals 28. Bring over 28 minus 12, this is 16. 16 divided by 8, your m is 2. Okay, moving on to question number 4. This is from the chapter Linear Law. So you're given a variable x and y, they are related by this equation. Diagram 1 shows a straight line graph obtained by plotting y over x squared against x. So we're supposed to express p in terms of q. All right, so number 1, what we can do is we can take this and convert it to linear form. Now, what to do depends on what is given on your y-axis and on your x-axis. You can see you're supposed to make this y square, a y over x squared as a subject. So I can take this equation and divide by x squared. Let me do it slowly. Divide by x squared. I'll have, maybe I just divide by 2 as well. Just get rid of the 2. So 2x squared. Picture this. If I take this and I divide by 2x squared, I'll get y over x squared. The 3, I got to divide by 2. The x squared, I've already divided it. No more. You're left with 4 minus x. So what we need to do is to expand or multiply this inside 1 by 1. So 4 times 3 is 12. 12 divided by 2 is 6. This is 3 over 2x. So your y over x squared is now negative 3 over 2x plus 6. So this is your big Y. This is your gradient. 3 over 2, negative 3 over 2 is your gradient. This is your x and this is your c. Right? So effectively, we've converted this to linear form. Now, for me, I like to reuse this or rewrite this as capital X, capital Y, because I notice a lot of people also tend to get confused. When we plot y over x squared, this is now your big Y. This is now your big X. Big Y means the variable on the y-axis. Big X means variable on your x-axis. And here we're supposed to express p in terms of q, meaning I need to take this coordinate and substitute inside. This is your p value now. This is your q value now. So by using capital Y, so I know my q is my capital Y, the whole thing. Yeah. Please don't go and put q over p squared, thinking that small q is your small y. It is not. Q is the whole thing, the y over x squared. Yeah, that's why I like to use capital Y first, and then I sub in the coordinate p and q. Your y is q, your x is p, right? And I'm supposed to make p as a subject. So let's bring this to the left, bring this to the right. My 3 over 2p is now 6 minus q. Let's make p as a subject. Now, there are 2 ways to write this. So we can multiply this over and write 12 minus 2q over 3. Leave it like this, which is okay. Or you can divide both of them by 3. 12 divided by 3 is 4. Then you minus 2 over 3q. There you go. You get your p in terms of q. All right, this is only the first part. I still have to do part B. Part B, they say, hence determine whether point 8 minus 6 lies on the straight line or not. So if the point lies on the straight line, very simple. If you substitute your x value with 8, your y value should be negative 6. So what we can do here is we take x equals 8. Now notice again, I use capital X, right? Capital letter, because the capital letter represent the variable here. This one from based on this equation is a variable in your x-axis. So let's sub inside. Your big Y is minus 3 over 2 times 8 plus 6. Okay, you can cancel, right? We can cancel this 2. You're left with 4 minus 12 plus 6. You will get minus 6. Well, your big Y is minus 6. Exactly. So we can say, therefore, this point 8 minus 6 lies on the straight line. Okay, question number 5. So this is from the chapter vector. So we are given the position vector of house A and B. They are 1, 2, 1i plus 2j. I would like to write this as in column vector, OA is 1, 2, and OB is 3, 5. Instead of writing ij form, writing column vector is a lot easier. So distance between the houses are measured in kilometer. Find the unit vector of AB. Okay, so before you find unit vector, let's find vector AB. Now, I personally like to use OB minus OA. Now, for some of you may wonder, why is it OA minus OB minus OA? So picture this. If I have point A here, point B here, if I want to go from A to B, I have to go from A to O, followed by O to B. Yeah? So basically, AB is A to O plus O to B. As we can put AO as negative OA. AO is going in the opposite direction of OA. OA is going up, AO is going down. Then we can just rewrite this as OB minus OA. Now, notice it's always the second letter respect to O minus the first letter A respect to O, right? So if it's PQ, it'll be OQ minus OP. If it's AB, it'll be OB minus OA. Now, my OB in this case is 3, 5. My OA is 1, 2. When you subtract 3 minus 1, you get 2. 5 minus 2, you get 3. So that is vector AB. Okay, I need to find unit vector. Now remember, unit vector is a vector that can be moving in any direction, but the most important thing is the magnitude is 1. So how do I make the magnitude 1? Well, by taking the magnitude AB and divide this AB with its own magnitude. So let's find out what is magnitude of AB. Yeah, we take the X value 2, you square it. The Y value 3, you square it, put the square root over. So this is 9 plus 4. 9 plus 4 is 13, right? Square root 13. Okay, unit vector of AB, we can write this with a U and a cap. This is the notation for unit vector. But if you don't want to write that, it's okay. We can just write unit vector. Now, we take this vector 2, 3, and we divide by its magnitude. Now, normally we don't divide by square root 13 like this, right? Instead, we multiply with 1 over square root 13, right? So there you go. That's your answer. Now, if you want to write in ij form, you can. This would be 2i plus 3j over square root 13. Okay, so that's part A. Part B. A new house C was built 13 kilometers from house A. The position vector of house C is given as 6i plus kj, meaning OC is 6k. We are supposed to find the possible value of k. Okay, for me, I will find vector AC first. And remember, as I say AC, we can use OC minus OA, the second letter respect to O, minus the first one respect to O. My OC is 6k. My OA is 1, 2. If you put them together, you get 5 with a k minus 2. Now, they say the magnitude is 13 kilometers. So to find the magnitude, we take 5, square it, k minus 2, square it, put the square root over, you should get 13. In fact, we know this is 5, 12, 13. So in fact, I would say k minus 12 square, minus 2 square, it should be 12 square. Or you can say 144. Now, you don't believe me, just use your calculator. 13 square minus 5 square, you should get 144. And square root of 144 is 12. But remember to put plus minus. There are two possibilities. Your k minus 2 can be a negative 12. It can also be a positive 12. As I bring over, k is negative 10 or positive 14. Yeah, two possible answers. Okay, moving on to question number 6. Okay, so here we have a shoe factory that started operation in January 2012, right? The sum of production of the shoes is represented by this function. That means this is your FT. FT is 150 plus 300T. T is number of years in which the sum should produce. Yeah, 2550. Okay, so very simple. You're finding what? You're finding the value of T, right? In which year the sum produced is 2550. So we're gonna put 2550 here and let us solve for T. I think it's a very simple equation. Just take 2550 minus 150 divide 300. So in this case, we should have 2550 minus 150 divide 300. This will give us 8, T equals 8. But we haven't answered the question yet because the question asks for which year. Now, the factory starts operation in 2012. So, right, and you're finding T is the number of years. That means when T equals to 1, right? So is the number of years we are finding. T equals 1 is year 2012. T equals to 8. For me, I'll do it this way. I plus 7. If you plus 7, the year is 2019. Right? Simple, right? So think it this way. Like, don't have to think too complicated. Yeah? From 1 to 8, I must plus 7. 2012 is the first year where T equals to 1. So you plus 7. 2012 plus 7 is 2019. Okay, part B, I'm going to do it here. A function gx is given as px plus q. You're supposed to find the constant p and q, right? The value of p and q, given that g of -5 is 11. G -5 plus 11 means I'm going to sub in -5 inside here and here. So we say p times -5 plus q equals 11. You can make p or q as a subject up to you, or we can just leave it like this. Call this equation number 1. Okay, the second part, your g inverse 2 equals to 7. Now, you don't have to inverse the function because we know that if, let's say, I start from 2, I go backwards. The object is 2, your image is 7. But if I go forward, instead of g inverse, we write g, your object is 7, your image is 2. So we put g7 equals to 2. Now let's take 7 and put inside your function. Yeah, this function here, p times 7 plus q equals to 2. We can say 7p plus q equals to 2. So what I need to do is to solve these two equations, equation 1 and equation 2 simultaneously. Well, I like to use equation 2 minus 1. 7p minus 5p. 7 minus 5 gives us 12p. The q minus q disappear. This q, when you minus with this q, disappear. And 2 minus 11 is -9. Your p is therefore -9 over 12. 9 over 12 is 3 over 4. Right? So take this p value and we sub inside equation. Any equation, maybe I put equation 1. My p is -3 over 4. I plus q. The result is 11. Just bring it over. This q is 11 plus. Remember, this is 15 over 4, positive. You bring it over, becomes negative. Yeah, -15 over 4. So this is actually 44 minus 15, which is 29. And you're left with 29 over 4. Denominator is 4. You can use your calculator if you're not sure. Yeah, you can just type in 11 minus 15 over 4. There you go, 29 over 4. Okay, question number 7. This is from the chapter Coordinate Geometry. So diagram shows straight line RU and RS. Straight line RS is parallel to x-axis and it has equal length with line straight line RU. That means RU, RS, they are of the same length. So you're supposed to find equation of perpendicular bisector US. Okay, first of all, we need to know what is the coordinate point point S. Yeah, if you want to find equation of perpendicular bisector, meaning we are finding this line joined together, find the equation of this perpendicular line. Now, before you find equation of this perpendicular line, we need to know what is the coordinate point S. So, number one, before you find S, we need to find what is the distance of RU, because RU, RS, they are of equal length. So let's start with RU. RU, we can use Pythagoras, simple Pythagoras, minus 3 square, 4 square, square root. RU is 5 unit. Okay, if RU is 5 unit, meaning point S must lie 5 unit to the right of point O. Yeah, to the right of point R to be exact, because RS is parallel to x-axis, the horizontal line. So we count 5 boxes to the right. So S in this case should be 5, 4. So therefore, S is 5, 4. If S is 5, 4, I need to find the midpoint first. To find the equation perpendicular bisector, we need to find the midpoint, right? Midpoint, let me call it M. It will be minus 3 plus 5 over 2, and then 0 plus 4 over 2. This will give us 1, 2. Okay, this coordinate is 1, 2. Now, next, let's draw a perpendicular line to it, right? This is your perpendicular bisector, but we need to know what is the gradient of US. Gradient of US will be 4 minus 0 over 5 minus 3. This is 4 over 8. 4 over 8 is 1 over 2. So I know US has a gradient of 1 over 2. And the perpendicular bisector has a gradient of what? Remember, M1, when two lines are perpendicular, M1 dot M2 equals -1. The gradient of first line US is now half. I'm going to put half here. To find out the gradient, we just multiply over, you get -2. So this green line has a gradient of -2. And to form equation straight line, what we do is we use y minus y1, mx minus x1. Now, some of you may want to use y equals mx plus c. You can do that. That's not a problem. I like to use this y minus y1. My y1, remember, I need to use the midpoint, which is 1, 2. y1 is 2, gradient -2, x1 is 1. Your y is minus 2x plus 2 plus 2. My y is minus 2x plus 4. So there you go. This is the equation of your perpendicular bisector. Okay, next, part B. Point B moves such that the distance from point R is always twice its distance from point U. Distance from point R is always twice the distance point U. So this is a locus. So I can rub this off. Nothing to do with the first part anymore. Well, you don't really need to draw it out. It's actually a locus of, we call it a constant ratio from two fixed points. It's actually a circle, but you don't draw it out. Yeah, your point can be here, right? Right, such that the distance is always twice from point U. Distance from R is twice the distance from point U. That means maybe it's here. This is 2. This is 1. Okay. So we can start off by saying R to P. P is a moving point. Divide by P to U. Yeah. Is 2 to 1. Or you can just say RP is 2 times of PU. Now let's use the formula for distance. P is a moving point. We use XY. Right? R is a fixed point, 0, 4. So we write X minus 0 square, Y minus 4 square. The distance is 2 times of PU. PU will be X minus 3. You write X plus 3 square, Y minus 0 square. So let's square both sides. When we square both left and right, the square root disappear. Maybe I square like this for you. Left and right. So this is X square. And for the Y minus 4 square, when I expand, I get Y square. 2 times Y times -4, that's -8 Y. And -4 square gives us positive 16. Now the 2 here, if you square it, you get 4. Expand this bracket, this will be X square plus 6X plus 9. And you have a Y square. Now let's simplify this by expanding the bracket. This is 4x squared plus 4y squared. Now I write the x first and y squared first, followed by I wrote down the x squared first, followed by y squared, and then 4 times 6, 24x, 4 times 9, 36. Okay, just rearrange it, bring everything to the right hand side. 4x squared minus 1x squared is 3x squared. 4y squared minus 1y squared is 3y squared. 24, nothing to subtract, we'll write it down. 24x. Negative 8, I bring to the right hand side, becomes positive 8y. 36 minus 16, you will get 20. All right. Okay, question number 8. So here we have a shopping mall that organized a contest. This is a permutation combination question. They have shortlisted 20 lucky contestants to be selected to win a main prize, which are the 3 cars, brand X, Y, and Z, and 5 consolation prizes worth 5,000 ringgit each. So the 5 winners from consolation prizes are drawn before the 3 winners for the main prizes are drawn. So find the number of ways in which the 5 winners for the consolation prizes can be chosen. Okay, so number 1, we know that there are 3 main prizes. Okay, the main prizes will be in a car, either X, Y, or Z, right? And then consolation, they are the same, right? Consolation worth 5,000 each. Yeah, 5K each. So the thing about the consolation prize is the order is not important. Whether you are the first person who got the consolation prize, or the second person or third person, you still get 5,000. But for the main prize, right? If you're the first person, maybe you will win car X. Second person, you get car Y. Third person, you get car Z. That's why there's a difference here. For consolation prize, it is not permutation because arrangement becomes not important. As long as you're one of the 5 people selected, you will win a consolation prize of 5,000 ringgit, right? So that's why the first part, how many ways 5 winners for consolation prize can be chosen? In this case, we are not using permutation. Instead, we're using combination. 20, choose 5, right? So we can use a calculator. Okay, let me show you here. Type 20, shift divide, that will be C, 5, you will get 15504. Yeah, 15504. Okay, now, next, find a number of different ways to select winner for the main prizes. Now, remember, you need to select consolation prizes first before the 3 winners for the main prizes are drawn. That means I have taken 5 people out for consolation prize. Then I'm left with 15 others. But for main prize, remember the order is important. First person get car X, second get car Y, third get car Z. So the arrangement becomes important because whether you're first, second, or third, you don't get the same price, right? So the number of ways to choose them, or in this case to arrange them, is 15 P3. Out of 15 of them, remaining 15, I arrange any 3. This will give us 2730. Yeah, the number of ways to select the winner is 2,730. Okay, next, the winner ceremony will take place in one event. So determine the different ways to seat the 8 winners in a line if there's no restriction. Okay, you want to seat the 8 winners. That means 3 main prizes, 5 consolation prizes. Okay, so if there is no particular condition, so I can actually seat any 8 of them in a row, right? Any 8 of them in a row is total. How many ways? 8, 7, 6, 5, 4, 3, 2, 1. We call this 8 factorial, or you can write 8p8. It's not necessary to write 8p8. 8 factorial will do, right? That will give us 40320. 40320. Okay. The second one. All prize winners are not allowed to sit. All main prize winners are not allowed to sit next to each other. So here's the thing. If you don't want the main prize winner to sit next to each other, you need to use the, those who got the consolation prize to sit in between, to be like a divider or a partition, if you like. So this is how we do it. We put the consolation prize winner, 5 of them, like this. Now, every time you put a consolation price winner, there's a gap in between them, right? We put a seat, empty seat. Then we put another one on the most left, another one on the most right. Since we have 5 consolation price winner, now notice there are 6 empty seats created between them. Yeah, 1, 2, 3, 4, 5, 6. And we can put any of the 3 main prize winner in the 6 different seats that we have, right? So anytime I put the main prize winner, maybe I put X here, the main prize winner for car X, and Y here. Notice they're never next to each other. I can put Z over here, they're never next to each other. They are always separated by the consolation prize winner, although this can be empty. So here we say we have 6 empty spaces. We arrange 3 main prize winner. Now remember, it's not we have 6 people to choose from. We have 6 empty seats. Yeah, we are putting in 3 main prize winner. So it's 6B3. Then we need to arrange the consolation prize winner. There are 5 of them. How many ways to arrange them in a row? 5 factorial. Okay, so let's use our calculator. 6B3. 6B3 multiplied by 5 factorial. This will give us 14400. Okay, moving on to question number 9. So this is first part is integration. So we're given that fx equals to 1 minus 2x power 4, and the integration of fx is now this. Find the value of mn. Okay, so very simple. Let us integrate fx 1 minus 2x to the power 4. Now remember, composite function. When you want to integrate ax plus b to the power of n, we need to copy the bracket, increase the power by 1, divide by the increased power, and we differentiate whatever inside the bracket. So this is a formula to integrate, right? So let's copy the bracket 1 minus 2x, increase the power by 1, 5, divide by the increased power 5, differentiate inside -2 plus c. So as I simplify this further, I'll get 1 minus 2x power 5 divide -10. Okay, maybe instead of writing dividing with -10, we write this as -1 over 10 plus c. Now, why do I do that? Because I need to find out what's the value of m and n. You can see from here, my m is the number in front, the coefficient. So my m is -1 over 10, and my n is the power for the bracket. So my n is 5. So to find the value of mn, basically we take -1 over 10, we multiply by 5, you get -1 over 2. All right. That is part A. Yeah? Quite simple, I would say. Okay, second one. This is a combination of differentiation and integration. Ali and friends are visiting a country, but on a particular day, Ali and friends will go to the theme park if the temperature of that on that day is not more than 40 degrees Celsius. Yeah, according to the weather forecast, the rate of change in temperature is given by this. All right. So can Ali and friends proceed with the plan if the temperature at 7 a.m. or P equals 0 is 22 degrees Celsius? So main thing is we need to find out what is the maximum temperature. Now we know in differentiation, a maximum and minimum when the gradient is 0. So if I were to draw a temperature versus time graph, now there are 2 possibilities. Yeah? You can have minimum, can maximum, but obviously this is a maximum. So maybe the temperature go up and come down, right? So at the maximum temperature here, the gradient of this graph d theta dt should be 0. Yeah, so we find out the time when we have a maximum temperature. So let's take this d theta dt and let it be 0. So your 0.45 minus t is your d theta dt is now 0. Doesn't matter when you have a 0.4. Now you divide it, it's still 0. 0 divided 0.4 is still 0. Your t is 5. Okay, meaning the temperature will be highest at 5 hours, at a time 5 hours after 7 o'clock. Okay, the problem is I do not know what is the temperature because I don't have a function for theta in terms of t. So I need to take this function and integrate. Remember, to find theta from d theta dt, we need to integrate your d theta dt. Maybe you guys are more familiar with dy dx. We know when we differentiate y, you get dy dx. When you integrate dy dx, you get back your y. Now, in this case, we need to integrate 0.45 minus t dt. Okay, it's up to you. Some people may want to times in. Maybe you times in easier. 0.4 times 5 is 2. This is 0.4 t dt. When you integrate this, you get 2t minus 0.4 t squared over 2. You can actually cut short working, but I purposely write one more step for you so you understand this 0.2 t squared plus c. But I need to find what is the value of c. That's why we are given this information here. When t equals to 0, your temperature theta is 22. This is your boundary condition. We call it when t is 0, theta is 22. Put 22 inside. Imagine this, if I put 0 here, I put 0 here, my c is actually 22. Therefore, my t is 2t minus 0.2 t squared plus 22. And to find theta, we know the temperature is highest or maximum when t is 5. So let's put 5 inside. 0.2, 5 squared plus 22. Okay, you can use a calculator. 2 times 5 is 10. Then you minus 0.2 times 5 squared. Then you add 22. This will give us 27 degrees Celsius. So your maximum temperature is only 27. So should he go out with his friend? Can they proceed with the plan? Of course, because you want the temperature not to exceed 40 degrees Celsius here, right? So this is your maximum temperature. So we know theta maximum is 27. Therefore, we can say they can proceed with the plan. Yeah, with the plan to go out. Okay. All right. Okay, question number 10. So here we have a question from probability distribution. So we have an unfair die. Normally we use the word bias. A bias die is tossed. The probability of getting a 6 is 0.4. If the die is tossed 15 times, calculate the mean. Now we know for binomial distribution, maybe I write over here, mean is given by mu equals NP. N is the number of trials. P is probably a success. So here we toss it 15 times. So your N is 15. P is probability of getting number 6. In this case, 0.4. 15 times 0.4 is just 6. You use a calculator. 15 times 0.4 is 6. Now, how about your variance? Variance is given by NPQ. Since I know my N, I know my P, and Q is the probability of failure. If your P is 0.4, Q is 1 minus 0.4, which gives us 0.6. So mentally, we can actually think 6 because this NP is 6, right? You multiply by 0.6. 6 times 0.6 is 3.6. Yeah, again, you can just take this calculator, multiply by another 0.6. There you go, 3.6. Okay, next one, part B. Find the probability of getting 6 at least once. So for me, at least once, the easiest way is to use 1 minus none. So picture this. If X represent number of times you're getting 6, right? And this is a probability. When you toss it 15 times, you can get 6 0 times, once, 2, 3 times, 4 times, all the way until 15. But it's going to be crazy if you try to calculate 1 to 15. So we know that the sum of all probability is 1. So by using 1 minus probability of X equals 0, I can find the probability of at least 1. At least 1 means 1, 2, 3, all the way until 15. So let's do probability of 1 minus none. So 1 minus none. Remember, your formula for binomial Px equals to R is given as NCR, P power R, Q power n minus r. I should use r here. So your n is 15, your r is 0, p is 0.4, r is 0 again, this q is 0.6, 15 minus 0 is just 15. So basically, we're taking 1 minus 0.6 power 15. And now, 15C0 is actually 0. It's actually 1, sorry. 0.4 power 0 is also 1. But we can just use our calculator and do 1 minus 0.6 power 15. There you go, 0.9995, right? I can just do one shot. I don't have to write this value r. 1 minus 0.6 power 15, 0.9995. Okay. Okay, question number 11. The first part, we have to use triangle method to solve it. You're given that cos theta equals negative m, such that theta is a reflex angle. Okay, if theta is a reflex angle, we know theta must be in quadrant number 3. Why? We know ASTC, that is in quadrant 3, only tangent is positive, cos should be negative. When we say reflex angle, it can be in quadrant 3 or quadrant 4. In this case, we have to take quadrant 3. Yeah? Okay, so let's draw a triangle like this in this direction. Cos is the ratio of adjacent over hypotenuse. Your adjacent is negative m. Your hypotenuse is 1. Opposite we can find. Yeah, we take 1 minus negative m square with the square root. This is square root 1 minus m square. Yeah, 1 minus m square square root. But please put the negative in front. Why? Because on the left-hand side of the y-axis, your y value, notice that your m here is negative. And below your x-axis, notice this one is negative, right? So your x-coordinate and your y-coordinate, they are both negative in quadrant number 3. So here we are solving for first part, cosecant theta. Now, if you read this theta is reflex angle. But if you want to find read sine cos tangent, we have to read the small angle here, the reference angle here. You can call it alpha. Doesn't matter. So your cosecant theta, we have to read this alpha here. Now, cosecant is 1 over sine. And sine of this small angle is your opposite. Opposite is negative square root 1 minus m square over hypotenuse. Hypotenuse is 1. So actually, you don't have to write the over 1 because we know it's going to be the same. So just leave it like this. This will do. Now, the negative, maybe it's best to put in the middle, but if you put below here, it's still okay. You can put in the middle. So it's negative 1 over square root 1 minus m square. So that is the first part. Okay, for the second part, I'm finding 5 secant theta minus 100t. Now, there are many ways to do it. There are really a lot of different ways to do it. But I think most people would probably use the addition formula. Yeah. Even the marking scheme here, they use addition formula. First of all, secant is 1 over cos. So I'm going to put 5 over cos theta minus 180. Now, remember, cos A minus B, if you expand, is cos A cos B plus sine A sine B. If it's a plus, then it will be a minus. The other way around, right? So you can expand this way. Later I'll show you another way. This will be 5 over cos theta cos 180 plus sine theta sine 180. Now we know cos 180 is negative 1. You can use your calculator, cos 180, but please use your calculator in degree mode. So cos 180 is negative 1, right? So this will be 5 over cos theta times negative 1. And we know sine 180 is 0, right? This is sine theta sine 180 is 0. If you don't believe me, calculator, sine 180 is 0. Now, for me, I just sketch a graph. For me, graph is the easiest way, the fastest way to find, but some of you may not. Remember, cos 180 is negative 1 here. At 180, cos is -1. Sine, on the other hand, it goes up and down. At 180 is just 0, right? If you remember, just sub in directly. So this is -5 over cos theta. And we can read cos theta from here. Cos theta is -m. So this is -5 over -m. Your final answer is 5 over m. All right. Okay, I don't have space for part B. So I'm going to do part B below here, over here. Now, so the first thing I'll do to solve this equation, sine 2a plus sine a minus tangent a. Now, we know sine 2a is 2 sine a cos a. This is from the double angle formula for sine. This formula is given in exam. U plus sine a. As for tangent a, we can change it to sine over cos. The result must be equal 0. So for me, I noticed that all three terms has sine. So I'm going to take out the sine a. I'm left with 2 cos a. Sine a, if you factorize it, you're left with 1. Take out the sine a, I'm left with 1 over cos a. The result is 0. Now we can actually combine this as a single fraction. Keep writing your sine a. 2 cos a times cos a is 2 cos square a plus cos a minus 1 divide by cos a. The whole thing is now equals to 0. Okay, the sine a over cos a, I can put them together. It becomes tangent a. If you want, I can write one extra step for you. This will be, okay, I'm just going to write tangent a straight away. It's a lot easier. Whereas the whole double bracket, this whole 2 cos square a plus cos a minus 1, we can double bracket factorize them. 1, 1 plus minus. So my tangent a is 0 and my cos a is half, or my cos a is -1. So there are 3 values. For tangent a equals to 0, we can find out from the graph. Yeah, I hope you remember the graph of tangent looks the same. Huh? All right. So it looks like this. So there are 3 values for a. A can either be 0, but in this case, be careful. We are not using degree. We are using angle in pi form. 180 in radian is pi. 360 in radian is 2 pi. For cos a equals to half, use your calculator. Change your calculator to radian mode. Shift cos 1 over 2. Now, cos, this is your reference angle, 1 over 3. There are 2 answers for cos a here. We can say the first answer is pi over 3. Now, we know cos is positive in quadrant 1 and quadrant 4, right? So this is up to 2 pi. Quadrant 4. Quadrant 1 is here. Quadrant 4 is over here. For quadrant 4, we use 360 minus, in this case, 2 pi minus. 360 in radian is 2 pi. So we're actually going from here to here, right? We need to take 2 pi minus your reference angle pi over 3 to get the answer. For cos a equals -1, on the other hand, I think we can just use a graph. -1 is over here, move across, move it up. We know this is pi. But you may notice that there's a repeat. There's a repeat in answer for the third one, because this answer a is only pi, and we already have a pi over here. Doesn't matter. The final answer, just write once. Okay, so for the second one, you have pi over 3. 2 pi minus pi over 3 is 5 pi over 3. So all in all, you have 3 answers from the first one, 2 answers from the second one. Maybe I arrange it. I put pi over 3 first. Then you got pi as well, 5 pi over 3. And lastly, you have 2 pi. Now, the third one you notice is pi, which I already have it over here. So I don't need to write one more time. You write once will do. So all in all, you have 5 answers: 0, pi over 3, pi, 5 pi over 3, and 2 pi. And 2 pi. Yeah? Yep. Okay, question number 12. So here, diagram 4 show ABCD. It's an agriculture expo organized, expo site organized by Eastern University. Point F is the center of the secretariat 10. So the distance of B is 3 times from the secretarial 10 and 4 times from point D. Now, I think this question, right, they should mention that that B, F, D, they are collinear. Correct. Yeah, they actually must mention that, because when you say the distance equals to 3 to 4, meaning F can also be here. F can also be here. The distance, this is 3, that is 4. Yeah. But the answer is based on the fact that they are collinear, right? All 3 points are on the same line. So I'm just going to use that, the fact that they are collinear. Okay. So when they are collinear, we know the ratio is 3 times from F and 4 times from D. That means this whole thing is 4. This will be 1. Remember the divisor of line segment formula? Point xy, if it divides a line segment, right? x1, y1, x2, y2, according to ratio mn, we use mx1 plus mx2 over m plus n, ny1, my2 over m plus n. Now, the most important thing is that the coordinate and the ratio must be opposite. For example, if this is your m, this is your n, the n you need to multiply with point D. The n, Malaysia m, you must multiply with point B. Yeah. So I'm going to use this formula here. So the point in between is F, and it's given a point F is the secretariat, coordinates of the secretariat 10. It is 15, 4, 13, 4, right? Now, let's take the ratio n, 3. You multiply with the opposite coordinate 3, and then m, which is 1, multiply with 3k, total ratio is 4. Now, we repeat with the y coordinate. We take 3, multiply with the y coordinate over here, 0. 3 is your n, you multiply with 0, plus your m, which is 1, multiply with 5k plus 3, 5k plus 3. Now, total ratio is still 4. Actually, we don't need to do both. We do one, because we are finding the value of k. So let's compare our x coordinate, 15 over 4. This is now 9 plus 3k over 4. Notice we can cancel. I'm comparing the x only here. We can cancel 4 and 4. We can bring the 9 over. Okay, let me do slowly. 15 is 9 plus 3k. 3k is now 15 minus 9, which is 6. K is just 2. Now, if you go and compare the y coordinate, you get the same answer. 13 over 4. This will be a 5k plus 3 over 4. We can cancel them. 13 is 5k plus 3. 5k is 10. K is also 2. Yeah, you can do either one. Don't have to do both. Yeah, it gives the same answer. Okay, next we are finding the area of the exposed side. That means area of this quadrilateral. Now that I know my k, right? I know my k is 2, so I'm going to sub inside. If your k is 2, 3 times 2 is 6, 5 times 2 is 10, 10 plus 3, 13. I know the coordinate point B is 6, 13. Okay, so to find the area, we can use in any direction, but you make sure it either go clockwise or anti-clockwise, right? So let's say I start with A. We use minus 2, 5. This is a formula for area of quadrilateral. X1, Y1, continue with X2, Y2, X3, Y3, X4, Y4, continue X1, Y1 again. Yep. And when we multiply, please multiply downwards here. Then you minus multiply upwards. Yeah. Okay. So the first one you should get minus 2 times 13 minus 26. 6 times 2 is 12. 10 times 0 is 0. 3 times 5 is 15. Then you minus the other way up. 30, 130, 6, and 0. Okay. This will give us minus 26 plus 27, which is 1. 30 plus 130 is 160. 160 plus 6, 166. So 1 minus 166 is 165. We can treat it like a modulus. Remember, if you choose the coordinate in the clockwise direction, whatever inside this will be negative. But since area can't be negative, we just take this, take the positive value, right? So drop the negative. 165 divided by 2 or times half is 82.5. Yeah, or you can write 82.5. Yeah, that is the unit. Question didn't mention what's the unit. I just write square unit. Okay, Okay, question 13. This is from the chapter quadratic function. So we have a diagram that shows a gate, and you have the upper part of the gate. It's a parabolic shape with a maximum height of 2 meters, all right, from the supporting pillars and width of 6 meters. So you're supposed to express the axis of symmetry, hence write a quadratic function in the form, in the vertex form, we call it, that represent the shape of the gate. Okay, so we know that if I were to, maybe I draw like this quaternary label here, this is your x-axis, and the width is 6. So this coordinate is 6, 0. This is 0. The height is 2 meters, right? So we know axis of symmetry is the line that divides this into 2 equal half. In this case, your axis of symmetry is 0 plus 6 divided by 2. Your x is 3. Yeah, simple. Okay, but to find the coordinate, right now, I hope you know this is 3. That means the maximum is 2. So we write this as 3, 2. This is the coordinate of your maximum point. Now, quadratic function can be written in a vertex form like this. Yeah, ax minus b squared plus q, where your maximum is now q, and that happens when the one inside the bracket x minus b is 0, x is p. So x equals to p is your axis of symmetry. And by comparing my axis of symmetry here with this one, I know p is 3. As for my maximum, it's already given here 2 meters. I can see it's 2 meters here. My maximum is 2. So by comparing my q with my maximum 2 here, we know q is just 2. So if I know p and q, I can now sub inside here. This is 3, this is 2, and we need to find the value of a. Now, please don't think that a is -1. A can be any value, but a has to be negative. So to find out the coordinate or the value of a, we can sub in maybe any other point. Of course, you cannot sub in 3, 2, because you try to sub in 3, 2. You try to sub in 3, 2, what would you get? Your y is 0, your x is 3, then you will get 0 here. This would be 0 plus 2, which doesn't make sense, right? We cannot find the value of a. So we need to take another point on the graph. In this case, is this point 6, 0. Let's sub 6, 0 inside. My y is 0. My x is 6, right? So 6 minus 3 is 3. 3 squared is 9. So this 9a. Bring the 2 to the left, -2. A is -2/9. So now that I know the value of a, I know my quadratic function fx is now -2/9 x minus 3 squared plus 2. Right? There you go. That's your fx. Yeah, in vertex form. Okay, then they say the municipality, pihak perbandaran, they should call it the local council, right? Wants to install 2 lights at point C1 and C2, such that PC1 equals to C1, C2, and C2Q. Find the height of the lamp from the ground. Now you can see that this length, and this length are the same. Maybe I just draw like this, okay? Now, if all 3 are equal length, and we know the length from P to Q is 6 meters, we just take 6 divided by 3, the value is 2. Meaning, this is now 2. And if you plus 2, 2 plus 2, it gives us 4. This 3 must be of equal length, right? Our job is to find the height of the lamp from the ground. So we know your x value equals to 2. Now that we know our formula for fx, right? We can sub 2 inside, -2/9, 2 minus 3 squared plus 2. Okay, use your calculator. -2/9, okay, -2/9 multiply with 2 minus 3, which is 1 actually. You can just square it, plus 2. You're supposed to give your answer in mixed number. Wait, I hope this is 1/7/9. Okay, but 1709 is not done yet. This is the height from point O, here to here. We're supposed to find the height from the ground. From the ground level, you have to add another 1.5. So your height from the ground is 17/9 add with 1.5. 1.5 or 1/2. So you add 1.5. You can use your calculator. 59/18 or 5/18. Yeah. Your answer must be written in mixed number. Okay, question number 14. This is from the chapter differentiation. So here we have a diagram that shows the curve y equals to 4x squared. So point S is on this coordinate 0, 2. R lies on the y-axis. Point Q lies on the curve such that RQ is P, and RQ is parallel to x-axis. You can see the length from here to here is P. All right, and the length of RQ is P. We are supposed to express area A of the triangle RQS in terms of P. RQS is this. This is your area triangle. Okay, so one thing you have to know that the height of your triangle here, first we need to find what is your y coordinate of point R. We know R is parallel to RQ is parallel to x-axis, meaning it has the same y coordinate as point Q. So first of all, we can sub in when x equals to P, because x is your horizontal distance P, your y is 4P squared. So the coordinate of point R is going to be 0, because it's on the y-axis, 4P squared, right? So this is 4P squared. So to find the distance of RS, I need to take 4P squared minus 2, right? This is 4P squared minus 2, the height from here to here. Now, area of triangle, we just use half times base times height. Maybe you can put P first, multiply with 4P squared minus 2. Now, let's expand this one by one, multiply inside. Half times 4 is 2, P times P squared is P cubed. Then half P times minus 2 is negative P. So your A is 2P cubed minus P. Okay, so I've got A in terms of P. Now, they say it is given that P is now 2. Hence, find the corresponding change in area A when P increases by 3%. Okay, so very interesting question. So, first of all, remember, this is a approximate change. When if today if I do sketch this graph, right, nothing to do with the graph here on the right, on the left, is, let's say, A versus B graph. When you increase your length B, right, from 2, you increase by how many percent? 3%. Your area A will also increase. Okay, but first we need to know what is the increment like for P. Initially, P is 2, right? When you increase by 3%, 3% of 2, 3 over 100 times 2 is 6 over 100. 6 over 100 is 0.06. That means the length P now increased by 0.06. I want to find the increment in your A. But we know delta A over delta P, when your delta P is small, is approximately the same as dAdP, not dAdx, dAdP, right? Now, dAdP means the gradient of the curve at point P, when P, in this case, P is 2. So we already have our A in terms of P here. What we need to do is to differentiate dAdP. When you differentiate 2P cubed, you get 6P squared minus 1, right? Differentiate negative P, you get negative 1. Sub in your initial value of P, which is 2. My dAdP will be 6/2 squared minus 1. 6 times 4, 24. 24 minus 1, 23. Okay, remember, we're finding the corresponding change in A. So when you increase the length, the area will also increase, right? That means we are actually finding this delta A. We know our delta P we're finding delta A. Delta A over delta P. Delta P we know is 0.06. The result must equals the ADP, which is 23. Now let's take 23 times 0.06. I will get 1.38. So my delta A is 1.38. Okay, so that is part 2. Yeah, I've done part 1. I better write this over here, Roman 2. Okay, part B. Point R moves along y-axis and Q moves along the curve such that RQ remains parallel to x-axis. Okay, so meaning we are moving RQ up so that it's not a triangle anymore. So this line is going up, your P is increasing. So as you extend, when you move it up, right, the P extend, then the Y value will also change. All right. Now they say by using the value P in A Roman 2, find the rate of change of distance of R from y-axis. R from y-axis is actually a Y value, isn't it? So as I move up my R further from the x-axis, my Y coordinate actually increases. So here, what is the relationship between Y and P? P is actually your x coordinate, isn't it? Isn't P your x coordinates? Actually, you can just write dy dx. But since they already define x as P, right? We can say your Y is your distance of point R from the x-axis. So I can say Y equals to 4P squared. Yeah, you can actually use Y equals 4x squared. Doesn't matter because x is the same as P. Yeah, as you can see, your P here, too many lines, sorry. P is the horizontal distance from here. As you increase your P, your Y value will increase. Yeah, your Y is this, X is your P value. So we're supposed to find the rate of change of the distance from R from x-axis. That means you're finding rate of change for Y. You're finding dy dt. You're given that P increases at the rate of 0.03. You're given dx dt, or in this case, dp dt is 0.03. You're finding dy dt. So here we have to use the chain rule. We break it up. dy, put a dt, add in a dp and a dp. So dp dt I can sub in. dy dp I have to find. I have to go back to this formula and differentiate dy dp. So as I differentiate 4p squared, I'll get 8p. Now let us substitute the initial value of p. In fact, we already have it. No, not here. P equals 2 here. Yeah. You will get 16, right? We know our dy dp, I can sub in. We know our dy dp dt, we can sub in here 0.03. We can find our dy dt. dy dt is 16 times 0.03, 0.48. Yeah. You can write unit per, this is per second. Okay. If you're not sure, just use your calculator. 16 times 0.03. There you go. 0.48. All right, last question, question number 15. So here we have a diagram that shows trapezium ABCD. ADE and BCF. There are two sectors of circle with center A and B. The radius are 8. Height of trapezium is 5. So meaning this is A, this is also A, this is also 8, right? Height is 5. You're supposed to find what? The first part is say the length of arc FC is given as 5.402. You're supposed to find angle CBF. CBF is this angle. Let's call it theta in radian. So the first part, we just use S equals to R theta. Very simple formula to find the length of arc. Since the length of arc is given as 5.402, your radius is 8. Can you find theta? Now let's take 5.402 divide by 8. My answer is 0.6753. 6753. You can write 525, but you don't need such a accurate answer. 4 significant figures is good enough, right? 5, 3 will do. Okay, next, you're supposed to find perimeter of the unshaded region. I personally find it a bit weird. Normally, we don't find a perimeter of 2 parts here. unshaded, we're talking about this length, this length, this length, this length. Then you add this length, this length, this length. Yeah, a bit weird. But anyway, you need to know how to find it. Okay, number one, we need to know what is the length from this end to this end. We know it's 5, right? Yeah, we already know that the height of the trapezium is 5. So, and likewise, this is also 5. I need to know what is the length from here to here. Maybe I call it G and I call it H, right? That means I find the length of AG and BH. AG and BH, they're actually the same, right? We know this is 8. We know this is 5. We can find AG. Okay, let me work it out separately, one by one. AG is 8 square minus 5 square square root. Okay, let's put a square root over. All right, 8 square, 5 square square root. So this is 64. 8 square is 64. 5 square is 25. You will get square root 39. Okay, so if this is square root 39, can you find the length of GE? Okay, right. Now, why is it important that I find this? Or maybe I'll find the length. You can find the length of GE first. This is what? 8 minus square root 39. Correct? And this is the same, 8 minus square root 39. This is square root 39. Now, okay, why do we find square root 39 first? Because we need to know what is the length from here to here, right? Okay. Well, that is the length of DC here. Now, you can see a D, okay, maybe I write here. I write this here. The GE is 8 minus square root 39. We keep this first. The length of DC, the whole thing is 25. 25, you must minus AG. In fact, you need to minus AG twice. This is your first AG here. This is your HB here. You minus both of them so you can find GH. And GH is the same as DC. I hope you can see that. So we take 25 minus 2 times of 8 minus 39. That is the length DC. Okay. Up to you. You can expand and simplify it, right? So DC is 25 minus 16 plus 39 times 2. Let me write times 2 here. This will be just 9 plus 2 is 39. That's DC. Okay. But we want to find the perimeter unshaded, right? We know DC already, but we need to, again, subtract this part of, should I use another color? I need to subtract this part off. Okay. So these are the same as my GE. Okay. So, okay, I know it's a bit annoying to find one by one. We can say that the perimeter, maybe we call this, we got GH, maybe I call it J, right? This is just J here. Now, this one you can do one by one. I thought of doing one shot because if you're finding perimeter, maybe we can find EH, right? EH, you plus, or should I say E straight away until the end here? Because you need a minus, okay, should I call it EB plus DJ plus the 2 arc, right? The 2 arc DE and arc FC, then you plus 8. 8 is your radius BC, right? So I hope I don't miss anything out. Okay, sorry, I need one more. I need FJ. Maybe I put FJ first over here. FJ, arc FC, ED, BC. Sorry, very long. So your EB is measured from this end to this end, which is 25 minus 8. Because this end is 8. Yeah, AE is 8. Correct? Then your DJ will be 9 plus 2 39 minus this part here, the JC. JC is the same as your GE, which is 8 minus 39. Okay, sorry, very annoying. Then you add your Fj. Your Fj is just 5. You add the length of two arcs. Now we know that both arcs has the length of 5.402. Then you add your BC. BC is 8. So the good news is a lot of things we can cancel actually. We can cancel 8, negative 8 and 8 here, right? The 39 actually you can add actually, right? So I will have to simplify this. I know this is a bit long. 8 minus, okay, let's see, 25. I hope I don't make any mistake. 25 is the whole thing. You minus your 8, you get the whole thing. This one is 25 minus, okay, I think I made a mistake here. Your DC is 25 minus 39. Sorry, I made a mistake here. 25 minus 39, twice of 39. Yeah, because there's a 39 on the left, 39 on the right. You're finding this DC first. This is DC, yeah? So, yeah, I'll keep it as this. So, this one, I need to minus 2 times. This will be 25. DJ is 25 minus 2, 39, minus 8 minus 39. Right? Yeah, you need to minus your JC. JC is the same as your GE, 8 minus 39. Okay, so the 25 plus 25, you can use a calculator to do one shot. So it's 50, right? And then you minus 2 39 minus minus. So you're actually subtracting 39 one time only. Okay, and then you minus your 8. Then you plus your 5. And then you plus with 2 times of 5.402. Okay, 51.56. Yep. I know this is a little bit annoying. It's not difficult, very annoying, right? Because you have to count one by one. All right. Now you may want to count like the grade 1 first, followed by the grade 1 up to you. But I thought we can just add in one shot. So I do it one shot like this. Okay, as for area shaded region, okay, let me rub this off. Too many things, very hard to see. Area shaded region is actually quite easy because your shaded region consists of, should I say, this is a trapezium. Look at this part first. This is your trapezium, right? You minus this sector of circle, but you got to add another sector on the right. On the left, this sector you flip over. Is it the same sector? It is the same sector, right? So you subtract the sector, then you add back the sector. So basically, you're actually finding area of trapezium, isn't it? You're only finding the area of trapezium. So don't bother adding and subtracting the sector. Now, for this trapezium, like previously I mentioned, we know JC is 8 minus 39. We know this is 8. We know the height is 5. So area trapezium is given by half sum of parallel side 8 plus 8 minus 39, right? Then you multiply your height. Your height is 5. So this will give us half. All right. 8 plus 8 minus 39, close bracket, multiply by 5. Okay, answer is 24.39. Okay. All right, I guess that's all for the discussion of this paper 1. Hope it's not too difficult. And yep, I hope you learned something from this discussion. Thank you and see you in the next video.